almost 3/4 of the earth is covered in water, and almost 3/4 of the electricity in the world is used within 200 miles of an ocean. If somehow you could put the two of these together, it would be a breakthrough in terms of how we generate and distribute electricity around the world. My name is Chris Sauer. I'm President, CEO of Ocean Renewable Power Company. We're not just a startup company with new technology. We're in a startup industry. How do you take moving water and turn that into mechanical energy? And then how do you take that mechanical energy, turn it into electricity, and bring it to shore?
The basic technology that ORPC develops is a hydrokinetic turbine. Machines that transfer that motion of the water into electrical energy from a subsea generator. In the design process, we're trying out lots of different things. And SOLIDWORKS environment gives you the ability to test those out virtually on the screen. We've got fluid dynamics design, we've got mechanical and structural engineering design, and we've got electrical machine design of the generator. And then you've got a framework to hold the whole device together. At that point forward, it becomes very much of a collaborative effort. And the group consists of the internal design team, external contractors, vendors, suppliers. This is where SOLIDWORKS really played a very important role in this project. My favorite functionalities within SOLIDWORKS are actually the SOLIDWORKS simulation tools. My background is really mechanical engineering analysis, so I'm a stress analysis type of guy. I really enjoy the ability to take a solid model and transfer it seamlessly over to the simulation environment and analyze the stresses and strains in the model.
We don't get a second chance, so we do have to design very carefully. We have two very large components that had to fit together with tolerances plus or minus about a 1/2 inch. So these two components had never been fit together on land. We determined that we needed to make some minor adjustments to 2 points on the turbine generator unit to ensure that they fit together. The first time that we had a chance to actually fit them together was 100 feet underwater.
2 feet on either side, Jake.
All right, coming down.
Roger, Andrew, go ahead and guide it over.
I think everyone was holding their breath as the final piece was lowered into place.
Coming down.
Coming down.
I mean, we know we'd done our homework, but we didn't really actually know till we got confirmation that they actually did fit together without even scratching the paint.
All stop.
All stop, Roger.
It's not like we can go to the internet and download the manual here. We're writing the manual. What we do is we solve problems every day. I can't tell you tomorrow what the problem is going to be, but we'll solve it.
We don't really know exactly what the answer is going to be. We try to come up with a design for a product, but nobody's ever designed this before.
You're talking about taking a concept that has never existed before, making some designs, turning it into a practical reality, and creating a new industry. That is the ideal career, I think, for any engineer.
At the bottom of all this, it takes a sense that you want to make a difference in the future, that something has to be done to change the course of history in terms of climate change. And we've developed that capability in-house. In fact, SOLIDWORKS has been part of that program.